Hi, in this video, I'm going to introduce dynamic routing protocols. Okay, so there's several types of dynamic routing protocols. RIP, it's not used too much anymore. EIGRP, OSPF, ISIS, and BGP. We'll be talking about some of these in other videos. We can also categorize these routing protocols different ways. Distance vector, link state, path vector, or interior gateway protocols or exterior gateway routing protocols. Let's take a look. Okay, interior gateway protocol versus exterior gateway protocol. Interior gateway routing protocol is a routing protocol used to exchange information within a single organization we call autonomous system or routing domain. When all the routers belong, all the networks belong to a single organization. Right? These are routing protocols like EIGRP, OSPF, ISIS, and RIP, if it's, some of that's still out there, but that's pretty much a legacy routing protocol. Okay, exterior gateway protocol. There's only one, and that is BGP, Border Gateway Protocol. That's a routing protocol used to exchange information between what we call autonomous systems, between different organizations, typically internet service providers, content providers, and also organizations as well. Many organizations connect with their internet service provider using Border Gateway Protocol to exchange routing information. Not all, though. Some will use something as you see in the lower right there, something as simple static route to do that. Okay, an autonomous system. Traditional definition from the RFC is it's a set of routers under the single technical administration using an IGP like OSPF or RIP or EIGRP, shouldn't even say RIP anymore, and a common metrics to route packets within that autonomous system. And then they using an EGP, Border Gateway Protocol, to route packets to other ASs. Basically connecting different organizations. It's when you are having to connect to somebody else's router, another organization's router, to exchange routing information. And we typically use a Border Gateway Protocol to do this. There is a kind of more current definition, which is a set of BGP speakers. We call those are routers that share same routing policy. This, you don't need to know that right now, but in later videos, I'll talk about Border Gateway Protocol. Okay, basic routing. What is routing? Okay, well, it's to find the best path algorithmically and operationally. It requires typically, and I'm kind of looking at kind of a very high-level view of this, but some sort of topology database, and these things will make more sense when we look at some of these routing protocols like EIGRP and OSPF in more detail. Hello messages to discover who our adjacent neighboring routers are and to maintain those adjacencies. Some sort of algorithm to determine the best path. Some sort of shortest path spanning tree is computed for each router. And there's two basic routing algorithms, Dijkstra, that's used for link state routing protocols, and Bellman-Ford, that's used for distance vector routing protocols. Okay, so what is the purpose of a dynamic routing protocol? Well, discover remote networks automatically, do this dynamically, okay, without any manual intervention from the network administrator, and maintain up-to-date routing information. Choose the best path to these destination networks, okay, and make sure that they're loop-free. So router R1 isn't sending it back to R2, that's sending it back to R3 and back to R1. Okay, and if the current best path is no longer available, to find an alternate path if one exists. Okay. And when topology changes do occur, that these routers are able to determine to discover these networks and find the best path do all this automatically. Okay, so in general, the operations of dynamic routing protocol can be, routers send and receive routing messages on their interfaces. And again, this all depends on the routing protocol itself. But it shares these routing messages and routing information with other routers using the same routing protocol. They exchange routing information to learn about these remote networks. And again, if there's topology change, it's all about advertising these changes to their neighbors, keeping each other up to date. We'll see how each routing protocol does this when we get into the details. For EIGRP, OSPF, BGP, and all of these. Okay, main components of routing protocols. Well, we have data structures, and these, again, high-level view. May include things like neighbor tables, topology tables, link state databases, and we'll learn about these when we get into the various routing protocols. But they typically submit their best path to the IP routing table. Routing protocols exchange messages, hello messages, updates, queries, again, depending upon the routing protocol, what kind of messages these are. This is how they learn about their neighbors, how they exchange routing updates, etc. And to determine the best path, they use some sort of algorithm, Bellman-Ford or Dijkstra. Okay, convergence. Convergence is when a network when all the routers in the network have complete and accurate information about the entire network. Convergence time is how long does it take routers to share this information when there is some sort of topology change, because inaccurate information can lead to temporary, even permanent routing loops. Okay? And a network is not completely operable until the network has converged. So if there's some sort of topology change in our network, how long does it take for all the other routers to learn about this change and also determine what the best path is to the whatever topology change, an alternate path, new path, whatever it might be, but did all of them agree on what that path is? Okay, we have distance vector routing protocol. So what does a street sign like this tell you? Okay, well, tells you how far something is and which way to go. Okay, that's what distance vector routing protocols do. They advertise vectors of distance and direction. Distance in terms of some type of routing metric. RIP uses hop count, how many routers away. Direction is simply what is the next hop router? What is the exit interface I use to send packets to that next hop router? Typically use the Bellman-Ford algorithm to determine what is the best path. Okay? But the only thing the routers know is how far something is and which way to send it. Okay? So they don't know a topology of the network. There's nothing more than going to a street sign. You don't have a map. All you know is which way and how far. You don't know if it's up a hill, down a valley, you got to cross a river, whatever it might be. And you don't know the exact topology. There's no map of the network. And that's all the routers know is what is the best in terms of the routing protocol's metric, what it uses to determine what the best path is. What is the best next hop router to get there? Okay. All right, link state routing protocols, well, that's different. They do use some sort of map. They have a topology of the network. Okay, so link state routing protocols use link state information to create this topology map. So the routers can select what is the best path to reach a destination network. Dijkstra's algorithm is the algorithm that's used for this. And it's very important that all the routers agree on what that path is. So you don't have one router thinking one way is better and another router thinking a different way, and that tends to lead to routing loops. Okay, so we'll explain more of this later when we get into link state operations, but it's all about sharing link state information. We'll get into this much more later, and using a topological database to then run the SPF algorithm, come up with the shortest path tree, and offer the best paths to the routing table. Don't worry about the details right now. We're going to be getting into that when we look at link state operations. Okay, so that's an introduction to dynamic routing protocols. A lot more to follow.